Hello, welcome to all. This is programming for problem solving course. Within this very important topic I am going to take, that is dynamic memory allocation. But before dynamic memory allocation, I'll somewhat cover memory allocation. Memory allocation, conceptually memory is divided. Memory is RAM, random access memory, program memory and data memory. I am considering this memory allocation related to our C programming. Main other functions and other along with their complete body. Data memory, global data and variables, local data and variables, dynamic data, main and other functions are here. So program memory and data memory, there are two partitions, global memory, heap memory and stack memory are holding data memory, and rest of the things are program memory. Heap memory is used to allocate to the programs during its execution runtime. Dynamic memory allocation is done using heap. We have two type of allocation schemes: static memory allocation schemes and dynamic memory allocation scheme. In static memory allocation, it requires that the declaration and definition of memory be completely specified in the source program at compile time. That means all the variables, all the arrays, pointers and functions are all defined at the time of compilation, and they cannot be changed at runtime. So dynamic memory allocation, opposite to the static memory allocation, the allocation of memory done at runtime when program executes, it's known as dynamic memory allocation. It uses predefined functions like malloc, calloc, realloc to allocate and free memory using free function. In this heap, dynamic memory can be accessed through a pointer only. Difference between static and memory dynamic allocation can be written in this way, and this is very important difference between both of these technologies. Static memory allocation, memory is allocated before the execution of the program, at which time we are performing this, and how bindings are being done statically or at runtime. This is whether it is permanently done and cannot be changed, and when the program is active. Stack memory and others are utilized here. Heap memory is utilized. Static memory is faster than dynamic memory. No special functions are required in static memory allocation, while dynamic memory allocation requires malloc, calloc, realloc and free functions. So we'll start with all these four functions. So four functions are there for dynamic memory allocation: malloc, calloc, realloc, and one function is for deallocating the memory we have allocated earlier. All these functions are defined in standard header file stdlib.h. So dynamic memory allocation. Dynamic memory allocation has various functions. So first function will be starting with malloc. So as per the syntax of the malloc, malloc, then within this parenthesis, parameter passed, single parameter is passed, and that is size underscore t size, and this function returns void pointer. So in this way, these are the different important points for this malloc function. So this size is actually number of bytes of which we want to allocate a block of number of bytes, and starting address of that block is actually returned by this malloc. Since at the time of malloc it doesn't know which type of values you want to store in this block, so it returns a void pointer. Then further, if we want to store integers in that particular block, then that void pointer will be typecasted to integer pointer and utilized accordingly. So unsigned integer, it is malloc.h. If no value is initialized within this allocated block given by malloc, then it will be garbage value will be stored within this. This malloc works from its task from heap memory allocation. Void pointer has been returned. If it is unsuccessful, then null pointer has been returned. A basic example is there. Even this example is not fulfilling this malloc function completely, but it is a basic implementation. So malloc function, size of float, size of operator we have to use, because sometimes we know data type size or size of each element that we want to store. Sometimes we don't know. If we don't know, then size of operator helps us, and it returns number of bytes required for this particular data type. Here it will be 4, and that float pointer is actually, because my pointer is float, so that PTR will point to a memory location. At that location some float value will be stored dynamically. Then next function is calloc, calloc or calloc. It has two parameters, size underscore t n, size underscore t size. That this size is size of each element, and this n is for number of elements for which this calloc function is being utilized. So this is similar to malloc function. In malloc, this size and this number are being multiplied by us, but here this multiplication is being done to calculate number of bytes by this function itself. And when this memory allocation is uninitialized, then it is initialized by 0, because it actually creates a block in the form of array. Malloc function never creates a block in the form of array. This is just a block, but here this is a block, a proper block, and it is in the form of array. So in array, if we don't initialize array, then it is automatically initialized with 0 if it is integer array, float, 0.0, character /0 depending upon the data type. Void pointer is again returned, and if a calloc function is not able to allocate its intended size, then it returns null pointer. The use of calloc function, so enter ptr I, then calloc function has been utilized here. In this function, 3 size of int. That means by this calloc function, a block of memory will be returned, and starting address of that block will be returned to ptr, and that block is capable of holding 3 integers in it. So 3 into size of one integer. So 3 into suppose 4, then it will be 12 byte size. So in this way, one array kind of blank array will be returned to ptr. So ptr will point to first, ptr will have address of first element of array, then +1 will give you second element, third element, in this way. So here in this for loop, I is equal to 0 less than or equal to 2, so I will be 0, 1, 2, 3 times it will run, and ptr plus I, ptr will plus 0. So first ptr will be having value 10 into 0 plus 1, that is 10, then 20, then 30. 3 values will be there as per this requirement. So this ptr pointed by ptr, this will be an array having values 10, 20, 30. So there will be, this will be printed by this also, right? So asterisk means value at address contained by ptr. So ptr has first element's address, then ptr +1 will be second element's address, ptr +2 second, third element address. So realloc function is a very special function. It did deallocate the old object pointed by pointer and returns a pointer to a new object that has the size specified by the variable size. The major use of realloc function is to resize the dynamically allocated object. That means malloc or calloc are already used, and there is a dynamically allocated block, and then realloc will work to change the size of that block. If ptr given to realloc function is null, then realloc will behave like a malloc function, and if second parameter, that is size 0, you have passed, then it will behave like a free function. So realloc function actually modifies the already allocated space. So example of the same is, first calloc function is being utilized for a particular size, and array has been created using all these values. Then realloc has been used for the same ptr pointer of the starting of array, or you can say array directly, and 2 more values are being added here. So now earlier 3 values will remain intact, and 2 more will be added, and 2 more will be added, will be filled with new values, and entire whole array is now of 0s to 5. So there are, for earlier there were 3 values, 0, 1, 2, 3 values, then 3, 4, 1, 2, 3, 4, 5, 6, overall 6 values are there. So 0, 1, 2, 3 we have earlier, and new values are 23 and 84. So realloc has actually modified that ptr array. Free function deallocates already allocated memory block. So after applying free, we cannot handle that memory block, and that memory block has nothing stored in it. It is free, and that memory block will be given to some other program, some other variable for allocation. So there is a difference between calloc and malloc. Calloc and malloc both are used for dynamic memory allocation. Calloc takes 2 parameters, malloc has 1 parameter. Calloc in uninitialized value will be stored in 0, but in malloc it will be garbage. Calloc is relatively slower because it performs 2 tasks. First is allocation, second is initialization. But malloc performs only 1 task, that is allocation. This is a simple chart for memory mapping in C language. In C language we have different parts, higher memory and lower memory is there, code segment, data segment, and this is stack segment. So stack grows up, heap goes down, and there will be some linear thin difference between them. So all the global variables, static variables, constants and literals are in data segment, and all the instruction that we have written in a program, that will be in code segment. So data segment will be fixed area, it stores global area, static variables, all these things. Stack segment has a stored area, this area grows up to a definite limit. So as you have done in recursion, whenever recursion is going infinite, then stack segment grows enough and it's exhausted, and no more further recursive call is done. So heap is dynamic memory allocation based memory, and it helps us. Code segment stores program code. Program using DMA, dynamic memory allocation. So dynamic memory allocation wherever dynamic memory allocation is being, earlier we have done these programs, but here dynamic memory allocation is being utilized. So PTR, enter the size. Now as per the user's choice, we will allocate a block using calloc in PTR, and PTR will behave like an array now. And if it is not possible, then it will if PTR is equal to null, that means memory is not available. Exit 0 will take us out of the program. Otherwise everything can be utilized in this program. So for loop will be done, entering of elements in that particular place, then summation has been done, summation of all elements we have done, then average has been calculated and average has been printed. After that task, PTR has been done free. Array of structures dynamically. Implement array of structures dynamically. Structure student, roll number, name, percentage. This is a pointer to structure. So calloc function has been used for three structure variable students. So 3 into size of structure student, and then loop has been initiated for struct strptr plus I. So all these values are being entered using arrow operator, because this is pointer to structure. So and arrow both are being printed, then these are printed as it is. Implement bubble sort dynamically. To implement bubble sort dynamically, only initialization of array, getting values array are dynamically. Then bubble sort logic is no more dynamic, it is a logic simply. So here I have not declared any array. Instead I have declared an integer variable, pointer to integer variable. Then float average, and all the float average is not required over here. Enter size of array. So as much the user size to sort these elements. Suppose user want to sort 10 elements, so array will be created dynamically for 10 elements only. Then calloc will create a PTR, and PTR will have n into number of n into size of one variable, right? Then further after that, enter the elements are being entered. Then this is simply bubble sort logic that you can go through it once and it will help you. So only this part is important here. So in exam it can be asked that you have to make a program dynamically. Dynamically means now instead of using array variable, you have to take a pointer variable. Using calloc or malloc, you have to make space for that pointer variable, and now pointer variable will behave like an array. Thank you.